Dear colleagues, we are glad to participate in the Modern Machine Learning Technology and Data Science workshop and present our paper towards understandability evaluation of business process models using activity textual analysis. Currently, business process modeling and notation, or simply BPMN, is a leading and, in fact, standard for business process modeling. The simplest BPMN business process consists of events and activities, where events represent things that happen in an instant, and activities are work units that have a given duration. BPMN models describe workflows as sequences of tasks and events connecting using control flows or sequence flows. They include also start events and end events that signalize beginning and finishing of business process. When describing a business process using BPMN graphical notation, the modeler should answer the following questions. When a new instance of the business process starts for the start event, when the instance completes for the end event, and what to do on the particular process step for activities. Events are usually named as combinations of nouns followed by verbs in past participle form, such as order received or order fulfilled, and the verb-object labeling style, like a verb in infinitive form followed by the noun, such as submit order, confirm order, etc., is recommended for activity labels. So the problem is that poorly described business process models are hard for understanding and maintenance, and these models cannot be efficiently used to document business operations, measure business performance, or find workflow errors that may reduce organizational performance. Existing studies mostly focus on structural analysis of BPMN model flow using the size and control flow metrics and the respective thresholds. But relatively smaller attention is paid to the textual analysis of activity labels used in business process models. This is why we propose our approach to measure the understandability of business process models that includes 4 major steps. First of all, we propose to process BPMN files and build the graph that represents business process models, then to analyze activity labels and calculate the textual quality metric, then compute metrics and compare them to word thresholds, and calculate the structural quality metric. After all, we propose to finally define the correlation between structural and textual quality of business process models and provide respective recommendations. The activity labels extraction from BPMN models is possible by representing a business process model as the labeled graph. The BPMN model is actually the XML document given according to the specific scheme. The process tags includes all core business process items such as events, activities, sequence flows, and other kind of elements. This is why it's quite easy to read such XML document and represent it formally using the coherent directed labeled graph. Then we propose the approach to activity labels analysis, which is based on natural language processing. It includes of multiple steps, starting from the tokenization of each activity label to get bags of words that correspond to each of the business process activity. For each word of tokenized activity, then, we propose to define one or several parts of speech to which each word belongs. Then for each activity label, we propose to check its length, and if the label consists of at least 2 words, we propose to check if the first and second words are verbs and nouns correspondingly. Finally, we suggest to calculate the textual quality as the ratio between the number of activities which labels match the verb-object labeling style and the total number of business process activities. Then, we suggest to formalize the structural analysis of business process models based on metrics and thresholds. First of all, we need to calculate values of the basic structural metrics to manage the business process model structural quality, such as numbers of nodes, start events, end events, and/or logic gateways, or sometimes called inclusive gateways. Then, using business process modeling guidelines, the following threshold values can be identified for the structural metrics we have given. So these are the following thresholds. Don't use more than 31 nodes in a single model. Don't use more than 2 start and end events, and don't use OR gateways. Then, using values of the basic structural metrics and respective threshold values, we can calculate the structural quality as the average of inverse sigmoid function results. The experimental results were obtained using the special Python's application developed using NLTK or Natural Language Toolkit package and other packages that helped us to process BPMN files collection and extract activity labels, tokenize activity labels, tag words, evaluate the textual quality, calculate structural metrics, evaluate the structural quality, and finally calculate the correlation between these metrics using the pandas package. The dataset was taken from the Camundus GitHub repository. It includes 187 models in English language that describe different alternative descriptions of goods dispatch business process, insurance recourse business process, credit scoring business process, and self-service restaurant business processes. And this Python application helped us to answer the research question, does the structural quality of business process models affect their textual quality? As we can see here from the table of correlation results, we can conclude that there is no relationship between textual and structural quality coefficients calculated for each of the experimental BPMN business process models. The first example given here shows that business process model of high textual quality could be of poor structural quality, having some issues, like here the OR gateway is used. And another example shows that business process model of high structural quality could be of poor textual quality. As we can see from this sample model, 4 of 7 activities have label and style that doesn't match the recommended verb object style. So we can conclude that the structural quality of a business process model doesn't mean its understandability, because there could be a bad correlation between these metrics. Demonstrated examples show how the models of high textual quality can be of poor structural quality and vice versa. So understandable business process models, which are valuable for the stakeholders, should demonstrate both high textual and structural quality. We recommend business process models pay for the textual quality and proper activity labeling as much attention as they pay to the structural quality of business process scenarios. And having a business process model both structurally and textually sound will make it serve its initial purpose to communicate knowledge about ongoing or planned business process. In future, we plan to implement automatic correction of poorly named activity labels in BPMN models and continue the study of the relationship between the textual and structural quality for business process models. Thank you for your attention and looking forward to your questions.